Hello everyone. Today we will be talking about this. So what this is it's just a voltmeter. And like for example, it can, if we stick the red wire, the probe, into the 5-volt section, we get a voltage close to 5 volts. If we stick it in the 3.3 volt section, we get roughly 3.3 volts. And also something interesting, you see these two resistors right there? You don't really see them now, but you see those two resistors? These ones right here. These resistors. Well, as it turns out, the two of them both make up a voltage divider, and the input pin goes into this 68 kilo ohm resistor, which goes into A0, and then this resistor is connected between ground and A0. So what this combination allows is that this multimeter, or this voltmeter, can measure voltages up to around 20 volts despite only running on 5 volts. And I can show you, for example, if we measure the voltage at this point, we get 11.5 volts because this is my 12-volt power supply that I'm just connecting over here. And by the way, this is pin 3 of this little voltage regulator here. And if we take a look at the center of this, wow, 12.3 and 11.53. And never mind this is just something that can be cancelled out by pulling the reset line low for a moment. Okay, maybe it does work. So, it can also be used to measure voltages that are... It can also be used to measure voltages not only within the circuit itself, but in other things. So, I have a supercapacitor right here, and if we prop it up with a thing of tape and measure the voltage between the positive leg of the supercapacitor and the negative, we can see that there's a voltage on there, 1.92 volts it seems like. And if we measure another one, yeah, there's a voltage on these because well, since I am connecting up the two grounds of it together, the grounds being the negative side of this capacitor and the main ground of the Arduino, then we can measure voltages. Although, unlike normal multimeters, voltmeters that can measure negative voltages, this one cannot measure negative voltages. I have not tried, but if I was to measure a negative voltage like this, it would probably... someone wouldn't be happy, is what I mean. So I may want to add a diode in there if I want to, but it may also be able to measure the voltage across this little DC motor when I turn it, or not. Maybe the DC motor is not producing enough voltage. Anyway, next, it wasn't all... This wasn't really you just plop your parts together and it's done. No. This main Arduino board, this had to be programmed. And this is the sketch that it is running. Well, here it is. So, I have labeled the line numbers, and I have highlighted all of the comments with a pencil, so just that. And, I am going to explain each line to you. So, first of all, this entire block of here is the is the comment, and then this is the first one. Include liquidcrystal.h, and this declares that the liquidcrystal.h library is being used. So in the Arduino world, libraries are used to help control different sensors. In this case, it helps control the little display that I'm using. And also, by the way, this is just a little breakout board that I added up to here. It doesn't really do much except it allows the LCD to be directly plugged into the one of the ports on the on my Arduino Mega. And so this basically tells us that we are using the liquidcrystal.h library. And this next line over here, liquid crystal LCD 53, 51, 49, 47, 45, 43. What this does is initializes the library with the pins the LCD is used. Change the numbers to move the pins. So pretty self-explanatory. These numbers just correspond to the pins that the LCD is using. And then void setup, so everything between these two brackets, the Arduino is only going to do once. So first of all, LCD.begin 16,2. This tells the Arduino that we're using a 16 by 2 character LCD, which is what I'm using. Then we LCD.print DC voltage, because if we put it back together by plugging the LCD in, and we don't really need to plug in the voltage divider, because if I just turn it on, then it will always run it no matter what. You see, it says DC voltage. And so that's what the DC voltage does. It prints DC voltage to the screen. And then LCD.set cursor 01. This sets the cursor of the LCD to column 0, line 1. Basically tells it to move to the second line of the display. Well, I guess it's more like line 2, since this would be line 1 and this would be line 2. But since this is computer, we start with 0 and then we start with 0 instead of 1. So this would be line 0 and this would be line 1. So just some weird quirks of the of computers. And then void loop, this everything in here we're going to do multiple times. So float raw equals analog read A0. So what this does is it declares a variable, raw, as a float variable, which means that it's a decimal point or a floating point. And then the raw variable is the same as the value read out of analog read A0. So the Arduino has a bunch of these analog pins for the Arduino Mega. It has pins A0 through A15. And those are all your analog inputs. I'm just using A0. But the Arduino Nano will have A0 through A7, and the Arduino Uno will have A0 through A5. So, just a warning. But I'm just using one of them, since this isn't like a 16-channel oscilloscope. Anyway, this value over here, it can be anywhere from 0 to 1024, and this raw value is this raw thing is just anywhere, whatever this analog read A0. It's the direct output of pin A0's ADC, or analog to digital converter. So this is always going to be any number between 0 and 124, an integer between 0 and 124. So then this float volt equals raw divided by 1024 times 20.5. So what this is it tells us that the volt, which is the actual voltage value, is the same as raw, but then we have to divide it by 1024 and then multiply it by 20.5. Basically, in summary, it declares and assigns a value to the volt variable. Volt is the actual voltage value, and this little math operation is just used to convert the raw value into the volt value. And then, never mind this is just the comments, and there aren't actual lines in the program. Then we lcd.print volt, which prints the voltage value to the LCD. Then lcd.set cursor 01. This sets the cursor back to 01 so that it can print the voltage value once it to restart the loop. during the next run through of the loop. So that's basically the program that the Arduino is running, and I will link the program in the description once this video is uploaded. So that's about it for today. Bye bye.